right, so in this problem, it says a bicycle starts from rest at the reference point and moves to the right. However, every second the bicyclist's speed increases 1 meter per second. What's the bicyclist's velocity after 3 seconds? So this is an introduction to the kinematic strategy. So this is a strategy you should use to solve kinematics type problems just like this one. So our first step will be to draw our motion map. Step one there says draw a motion map. Motion map always starts with a position line where the beginning of it shows the reference point and the direction it points in is the positive direction. So next we want to draw the velocities. It says that we're starting from with zero velocity because the problem says the bicycle starts from rest. So we just draw a dot to represent the velocity right there, and we draw it right at that point because it says it starts at the reference point. Then a split second later, we know that the velocity increases 1 meter per second. So now the arrow points to the right because this is a positive increase. So 1 meter per second is to the right. And then the velocity increases another 1 meter per second. So it went from 0 meters per second to 1 meter per second to another 1 meter per second. So that's 2 meters per second. So 0, 1, and 2 meters per second. Then finally, it increases another meter per second. So now it's going 3 meters per second. So notice the arrows increase each time. Now we want to draw the dreaded acceleration arrows. Remember, I like to call these the change in velocity arrows or vectors. Now remember that acceleration is the change in velocity, and whenever we calculate a change in physics, it's always final minus initial. So let's look at this final velocity right there. We're going to call it the final velocity for the first second. That velocity minus that velocity would be equal to that change in velocity right there. So think of it this way. This length minus that length is equal to that length. All right? So the change in velocity or the acceleration is that length there. And in this case, because it's 1 meter per second right there, and I'm subtracting 0, this change in velocity is 1 meter per second. Then we go from this velocity, that final velocity, to this initial velocity. So that length minus that length is that length there. Okay? And then this length here, this 3 meter per second length, minus that 2 meter per second length is, again, a change of velocity of 1 meter per second during that second. Okay? All right, so that's step one, drawing the motion map. Step two is writing the 5 kinematic variables. So that's step two, it's just writing those 5 kinematic variables out. And those represent the x is the position or displacement, that's the initial velocity, the final velocity, the acceleration or change in velocity, and the time. Okay, and so these are the things that are given to us in the problem, these values. Step 3 is to identify which of those variables are known and unknown. So we've got to go back to the problem and read this. So I'm going to use these different colors to determine what's given to us in the problem, what's not. The position really isn't ever given to us, that final position, that X stands for final position, that's never really given to us. We could probably figure it out, but it's not explicitly given to us in the problem. The initial velocity is 0 meters per second. We know that because it says it starts from rest. We drew a dot to signify that. The final velocity is what we're looking for. It says, what's a bicycle's velocity after 3 seconds? The acceleration, now this is a little tricky because it says the bicyclist's speed increases by 1 meter per second every second. So that's the definition of acceleration. How much does the velocity change? So the velocity change 1 meter per second every second. So that's the acceleration or the change in velocity. Finally, t, the time is 3 seconds. So the three blue things that are highlighted there, the initial velocity, the acceleration, and the time, are the things we know. They're given to us in a problem, or we can figure them out from a problem. And v sub x is what the problem is asking us to look for. So we need an equation that has all four of those variables, the three we know and the one that we're looking for. So that's step 4. We got to find the equation that has those four variables. So we have to look at these equations, our kinematics equations, and ask ourselves which four of those variables are in one of those equations. And it turns out that it's this first equation right here. That first equation right there. So that says final velocity is equal to initial velocity plus acceleration times time. So that's step 4. And finally, step 5 is what the engineers call plug and chug. In other words, just plug them into the equation and come up with an answer. So the final velocity is equal to the initial velocity, which is 0 meters per second, plus the acceleration of 1 meter per second, or 1 meter per second squared times a time of 3 seconds. So it gives us a total or a final velocity of 3 meters per second.